to lesson P5. We're going to talk about functions. Relations first, and then we'll get into functions. And you'll eventually do a practice on just plotting some points and vertical line test, essentially. So first definition, a relation is a set of pairs of input and output values. So just a collection of ordered pairs, essentially. You can write a relation as a set of ordered pairs. So here's some information you're given. So the input is the time in seconds, and the output is the number of steps. So what we can do is write them as ordered pairs. So the ordered pairs would be, again, it's like one at each. So the ordered pairs would be 0, 0, 1, 2, 2, 4, 3, 6, and then 4, 8. All right. So the next step would be then to take that collection of ordered pairs and graph them. Only thing you got to remember is the first number is your x coordinate, your second number is your y coordinate. The x coordinate is going to tell you whether to go left or right, whether it's positive or negative, negative left, positive right. The second number y, positive up, negative down. So negative 2, 1 would be left 2, up 1. Negative 1, 0 is left 1, and then no y movement at all. So right there. 0, 1 is not moving at all left or right, and then 1 for the y makes it go up 1. And then 1, 2 would be right 1, up 2. Something that you're also going to see in the practice is you're going to label the graph in quadrants, right? So you have a coordinate plane. The y-axis and the x-axis cut the graph into 4 parts, quadrants. What's considered the first quadrant is where both numbers are positive. And this is in Roman numerals, so it's really just like a 1, right? The second, and it's going to just go counterclockwise. All right, so then the second quadrant is over here. That's Roman numeral for 2. So that's where the x values are negative, but the y values are positive. The third quadrant is the one down here. Again, that's Roman numeral for 3. And that's where both the x and the y are negative. So when everything's negative, you're down in the third quadrant. And then the fourth quadrant, again, Roman numeral for 4, is where the x is positive and the y is negative. All right, so every ordered pair is in one of those quadrants unless it's on one of the axes, okay? Let's plot these points over here for the second part of example 1. Negative 3, 3 would be left 3 and then up 3. So if we were talking about quadrants, that's in the second quadrant. 2, 2 would be right 2, up 2. That would be in the first quadrant. Negative 2 would be left 2 and down 2. So now that point is in the third quadrant. 0, 4 is not moving left or right at all and going up 4. So that's not in either quadrant. I guess you could say it's straddling the line between first and second quadrant. And then 1, negative 2. So right 1 and down 2 is right here. So you would consider that in the fourth quadrant. Couple more definitions. Domain is the set of all inputs or x coordinates of the ordered pairs. Big thing you want to remember is domain is x. It's all the x values. Range is the set of all outputs or y coordinates of the ordered pairs. So range, what you got to remember is y. This is just the reverse of the first example. So first example, they had us plotting points, right? So you got the relation, you had to make the graph. Here, we're going to do the opposite. We're going to take the ordered pairs off of the graph, right? And then that would be the relation. We're just going to list out the ordered pairs. So this point right here is 2, 4. This point right here looks like it's 3 and then 4.5. I'm just going to mark them off as I go. That point there looks like it's 4 and 7.5. This point right here looks like it is 3, 7. This point right here looks like it's 6, 5. Then this point right here looks like it's 6 and then 7.5. Okay. Second part of the question was to list out the domain and the range. So if I'm going to write out the domain, I'm going to put it in brackets like that, and you're just going to list every x coordinate, and you're not going to repeat. I'm going to put them in numerical order. You don't necessarily have to. 2 is the first one, and again, I'm just listing out the x coordinates. 3 looks like the next one. We have 2 different 3s. I'm only going to write it once. 4 looks like it would be the next one, and then 6, there's 2 of those. I'm going to write it once. And then that's your domain. Your range is going to be the same thing, just with the y coordinates. So it looks like the first one would be 4. Looks like the next one would be 4.5. Looks like the last one would be 5. Not the last one, the next one. Looks like I have 7. And the last one is 7.5. Okay. You're going to do the same thing with the part B of the example. I'm going to leave that one for you to try on your own. I don't want to make the video too long. All right, but you get the idea with A. You can try it with B, but it's just write out the ordered pairs. Domain is going to be the x values. The range is going to be the y values. Then the only other thing you got to remember is you don't repeat the values. You would never put the same number in twice for domain or range. A mapping diagram links elements of the domain with corresponding elements of the range. So what we're going to do is write out domain and range just vertically. So this is giving you the relation. So I have all the ordered pairs. I'm now going to list out the x values in the first column. So the domain is going to be here. The first number, and again, I'm just going to put them in numerical order. -5 appears to be the first one. All right, and then -1 appears to be the next number. And then 3, which is listed twice, I'm going to write once. Okay, then I'm going to write the y values in the second column, label that the range. The first number appears to be -10. Then it appears to be -2. Then it appears to be 2. And then 6. What the mapping diagram has you do now is connect the domain to the range. So I look at the first ordered pair. -1 connects with -2. So I'm going to draw an arrow from here to here. Notice how it's from the domain to the range. You're not putting arrows on both sides. The next ordered pair is 3, 6. Connected that way. The next ordered pair is -5, -10. You connect it that way. The last ordered pair is 3, 2, and you connect it that way. Okay. We'll do the same thing quickly over here. -1 and 1 appear to be the numbers for the domain. 3 and 7 appear to be the numbers for the range. Connect them. So -1 goes to 7. 1 goes to 3. And then 1 goes to 7. And then -1 goes to 3. Okay. A function is a relation in which each element of the domain is paired with exactly one element in the range. So is this relation a function? It has to be exactly one. So where you look is in the domain, do you see a place where there's more than one arrow coming out? In this case, there is, so this is not a function. For this one, each element in the domain has exactly one arrow to a different element in the range. The fact that you have two elements in the range where the domain is pointing at it is okay. Again, I'm only looking at the domain. Does each element of the domain have one arrow coming out of it? It does. This is a function. Last one here, looking at this element in the domain, it's got two arrows coming out of it, not a function. Okay. Relations can be represented as discrete data points that don't follow a pattern, as well as by lines or curves. So what we've looked at so far is discrete data points, just like a collection of ordered pairs. But relations can also be lines or curves. A vertical line test is what you would look at if you were just given a graph. The vertical line test states if a vertical line passes through two or more points on the graph, then the relation is not a function. Essentially, comparing that to the mapping diagram that we just talked about, a function that has an element in the domain that has more than one arrow coming out of it would fail a vertical line test because a vertical line would touch those two places. All right. So if I look at the first one here, any vertical line that I draw on this graph is only going to touch the function once. So this is a function. This one here, if I draw a vertical line there, touches there, not a function. This one here, no matter where I would draw a vertical line, it's only going to touch it once. So this one is a function. This one a little trickier, but if you draw a vertical line in most places, you're going to touch it either 0 or 1 times. However, if you draw a vertical line here, you're going to touch here and here. Also, it would fail there. The fact that it fails one place means the whole thing fails. Doesn't matter that it would pass in other places if you draw a line. So this one's not a function. All right, a function rule expresses an output value in terms of an input value. So a function rule can look like an equation. This is function notation, but it's the same idea. It's the same thing. And then this is a formula where, again, something is equal to something else. It doesn't look like y equals x or whatever, but by the way, this would be for circumference of a circle. For the one that's the function notation, this f parentheses x, you read this as saying f of x or a function of x, but I'm going to say f of x almost every time. It does not mean multiplication, okay? If you see notation that says f of 5, and that's how you would say this, f of 5, it's basically asking what's the y value when x is 5. So you're going to substitute 5 in for x everywhere there's an x. So that's what we're going to do here. This is the function, and then it's asking 3 different questions. F of 2, let's do that first. F of 2 means I take this function, and everywhere there's an x, I substitute a 2 in. Just be careful with this one where the exponent is only on the x, not the negative sign. So the negative sign is multiplication separate. 2 squared is 4, then that negative sign will make it negative 4. Negative 4 plus 1 is negative 3. So f of 2 equals negative 3, meaning with that original given function, when I substitute 2 in for x, I get negative 3. That's what that means. For f of negative 4, I'm going to substitute negative 4 in for x. and then evaluate. Again, that negative sign is this one here. Inside the parentheses, I have -4 because I'm substituting -4 in for x. -4 squared is 16. That negative sign is going to make it -16. And plus 1 makes it -15. So f of -4 equals -15. Notice how on the last notation that we're going to do, 2f of -2, there's an extra 2 out there that's multiplying. So what that means is you're going to put an extra 2 out and multiply what you get here. So that's, again, negative. And then for x, you're going to substitute in -2 squared plus 1. But again, that 2 that's outside the function notation on the left side is going to be now outside the right side. Simplify what's inside first. -2 squared is 4, and that negative sign makes it -4. -4 plus 1 is -3. And now that 2 that is out there, I'm going to multiply and get -6. So 2f of -2 is equal to -6. Okay. I'll leave the other 2 for you to practice on your own, but you would do the exact same thing. So for f of 2, you're going to substitute 2 in for x here, and on the one before that, you would substitute 2 in for x there. For the one that's f of -4, you'll just substitute -4 in for x and simplify. So here you just do 3 times -4 and take the absolute value of that. Here you'll substitute -4 in for x here. 1 minus a -4 is 5, so 9 divided by 5. I just leave it as 9/5. All right, then the one that's 2f of -2, substitute -2 in, and just multiply by 2 at the end. All right. Give those a try, and then the practices are already posted. So you can go ahead and start those and then reach out to me if you have questions.